Okay, I'm doing the second. This is the first sheet we just did. I'm gonna go to the second one. Hold on 1 second. Let me go ahead and grab it here. Wait, did something happen? Oh, it's already over there. That's what it is. All right, we're gonna do multiplying. That's it right there. I really might not do this because there's a few things we don't understand. Excuse me. Yeah, I'm gonna wait to get back to class for this one. We have to learn how to multiply binomials. Well, not really binomials, multiply numbers using distribution. We really don't know that. I'm not getting a sense we know that. So we may have to go back to that too. We missed a lot of school, some things we may have to go back to. But let's go to the next sheet. All right. This is the next one. This is the powers of I. I want to thank Joshua Motley for making this simple, and also Grayson Johnson, although I haven't really established what he has done yet. But he made a very good observation I didn't make till I was in college, but his is important also. So let's just, I won't use Grayson's idea. It'll make it easier here, but I will definitely use Motley's, and I will use the rotator. Okay, I'll try to explain both in a minute. In fact, I might do that right now. Let me go to a clean sheet of paper. Let me do that. No, I didn't want you to see that. Let me do it over here first. There we go. No, blank. All right, bringing it over now. All right. Um, finding I, uh, finding powers of I. I should type this. My handwriting is pretty ugly. Hold on. Let me change this to something bigger. Maybe 16. And use Times New Roman. Nah. When it comes to math, Cambria is better. I know you don't know what that is. Don't worry about it. I've been doing this a long time. And actually says math on it. Oh, well, not anymore. So let's go back up here. It should be under Cambria. Oh, Cambria math right there. Okay, I got it. All right. Can we see this? Well, I'll make it a little bigger. All right, there we go. All right. Ending oh man, I gotta keep it lowercase. Um, Let me make this look a little bit different. There we go. That doesn't make it look any better at all, does it? All right, let me go to my symbols. Let me get a good symbol here. Maybe I should have done this before, but let me find a symbol. Oh, symbols. It should be in layout. No, no, maybe it's in view. No, design. No, draw. Yeah, here it is. Where are my symbols at though? Interesting. All right, let me see. See what comes. All right. There we go. That looks good. Is there an I up in the symbols? I couldn't find these symbols earlier. I don't know where they were at, but I couldn't find them. Okay, I can't find it. I'll worry about it later. We'll find that later. All right, let me go back to insert, draw. There you go, ink to math. Make another I. Insert. All right. Why is that back to 11? Yeah. Shouldn't. All right, finding powers of I from I, A, using the 90, where's my symbol for degree? All right, hold on. Yeah, where is that? I usually have some symbols I could use, but oh, here they are. Okay. All right. This is a long way to find the 90-degree thing when I can just write degree. But to all right, I'll just write degree. It's really getting up. Shouldn't have took that long. All right. And B, using, oh, wow. Not sure why it's doing that. Make this bigger. There we go. B, using multiplication. They're actually both good ways. Oh, okay, I can use that. I just did it when I was younger. I used multiplication, and I like the rotator level. And actually, Holly told me a better way to explain it. Thank you, Holly. All right, A. Why is it doing that? There we go. Okay, the rotator method. All right. You'll be multiplying. Let me get some more space. Be multiplying I. So I'm gonna use red and black. This is my graph. This is the real line. This is the imaginary line. All right, and I'm gonna use red to add to the thing. It looks like red. All right, we'll call this 1 I, -1, -I. All right, what a lot of us had trouble doing, we didn't know where to start. Do we start here? Okay. Or do we start here? Okay. So let me help you. What Holly explained to me, she said that we start here because remember, the first thing we're dealing with is I to the 0 power, which is 1. And of course, the next one is I to the first power, which is I. The next one, I squared, which you can see is -1. Could have did that further. And I should use a different color. Green, let me see. Okay. And then back to black, we have I cubed, which is -I. And then I to the fourth, which is back to 1. All right. Oh, sorry. All right. So that's it, the rotator. So if we see anything like this, we break it down to 4, 3, 2, or 1. Of course, I to the 4 and I to the 0 are the same thing, but we understand why we start right here. All right, start. Okay, the rotator is the same thing as the multiplication, except you don't have to memorize anything. So our first one was actually I to the 73. So pretty simple. We do 73 divided by 4. This is Motley. Thank you, Mr. Motley. Very good. We divided by 4. We're going to get, really, we know 4 goes into 72 and there's 1 left over. But for those of us that have trouble dividing, we should continue. So we got 1 here. 1 times 4 is 4. We got 33 and 8, 32. Our remainder is 1. That's the important thing. Our remainder. As you get further along, these are called mods, but you didn't hear that from me. All right, we had a remainder of 1, or mod 1, and we always start at 1, so we're going to start here. I don't know what color I'm going to use. Oh, I'm going to make a new graph. All right, make a new rotator. I start here, 1, and this is I. So I to the 73, it's just I. All right, what's the next one? Hold on, let me look at it. I know the first one was I to the 73. The next one is I to the 259. All right, let's move down. I to the 259. All right, so we do the same thing Motley taught us, 4 as it goes into 259. So we have here 4 times 6 is 24, 19, and this is going to be 16, so that's going to be 4, 16, 3 has a remainder, or mod 3. I'm not going to say that again. All right, 3 is a remainder. We make our graph. 1, 2, 3, and that's negative I. Okay? And so this answer is going to be, I'll put this in red. Negative I, while this one is just I. All right. That is pretty much it for those. I can't imagine them being any harder than that, but I'll still do a few examples. But next, I got to go over the multiplication method. Hold on. So let me, oh crap, I got to, see, this is what I hate, why I hate this. Okay, I shouldn't say hate, dislike. Let me use that word. Oh man, it shouldn't have happened. Okay, hold on. It's moving the whole thing down. I didn't want to do that. Oh, okay, it's coming down. All right. Uh-oh. Backspace. I'm having trouble getting rid of this footer. Oh, there we go. Okay, I got rid of it. Let me see if I can push enter now. Uh-oh, did something happen? Oh, the whole thing went down again. Okay, hold on. Oh, I got it. There we go. All right, I don't know why it's going to the left. Maybe to the right. I just moved it back. All right, so next we have B, multiplication. I don't know why it's doing that. Let's try this again. Okay. All right. Oh, let me just write it. Oh, should be black. All right, B. Multiplication just says I to the 0 equals 1, I to the first power equals I squared equals -1, I cubed equals -I, and I to the fourth equals 1. You should have memorized that. That was it. All right. Now, same thing applies I to the 73. We put it 4 into 73. We're going to get, what is this? 18, remainder 1. And we go to I to the first power. We get I. All right. You have to memorize that. Now, the next one, I to the 259. 4 goes into 259. I forgot what that was. Well, I'll just do it again. That is 64. What is that? 256. Remainder is 3. All right. So we memorize I cubed will be -I, and the answer is going to be -I. I should put that in red. -I here and I here. If there's another difference, let me know. I'll be happy to show that. All right. With that being done, let's go back to our paper. I wonder, I should save this and put it in the thing anyway. Hold on, let me save it. Save as, put it in algebra. Let's go to browse. I'll do this later. I shouldn't be wasting your time. All right. Let's get started. Make this a little bigger. We already did I to the 73, I to the 259. We know this is going to be I. We know this is going to be I. And this is going to be -I. I to the 24th. 24 divided by 4 is just 6, whole number. That's just going to be 1. I to the 16th. 16 divided by 4 is 4. That's a whole number, meaning there's no remainder. So I shouldn't write it like that. I shouldn't. I can, but I write the other one like this. We get 4, so this is going to be 1. All right, 543. 543 divided by 4. 4 into 543. What is this? I think it's going to be a remainder of 3, because it's 4. Let's see, this is 1, 5, 14 is going to be 3. And that's going to be 23. That's going to be 5 with a remainder of 3. Remainder of 3, using our rotator, 1, I to the first power, I squared, I cubed, -I, -I. I to the 9th, same thing. 4 goes into 9, remainder of 1. Make our rotator 1. It's going to be I. This is getting kind of boring. I know. Let me see if I can find something harder. Nope, I cannot. All right, part B, simplify. Same thing. All right, let's get started. I to the 486. That is not divisible by 4. It's actually a remainder of 2. So it becomes -1. 29. That's 1 over. That becomes I. 7. That's remainder of 3. That becomes -I. 80 is going to be +1. So let's do the real part and imaginary part. The real part says -1 plus 1. The imaginary part says plus I minus I, 0, 0. So I'm going to get 0 plus 0I, which is equal 0. I can't imagine being, let me see, is the answer to this one? Let me see. Yeah, it says 0. Okay. Next, this is the same, it's just as easy. 8 plus 675, it's going to be I to the 683. We divide by 4, and I'm going to get, I think it's going to be I, but let's make sure. 4 into 683. This is going to be, I was wrong. It's going to be negative I. 1, oh yeah, it would be. I feel bad. All right, 1, then 28 is 7. And then this is just going to be 0 with the remainder of 3. So this is going to be negative I. I'm sorry, this is kind of simple. This is simple. I mean, I can't, I don't think I should do anymore. All right, I'm gonna stop the video here.